A little bit about me. I'm Janez Kranjc. I work at CargoX. I used to be a data scientist for a while, a web developer, but currently I'm working with blockchain technologies at CargoX. What we're doing is we are taking a document called the bill of lading and we're putting it on the blockchain using smart contracts. Today I'm going to talk about smart contracts and how to get people to interact with them without So, let's start. What is a smart contract? So, a smart contract is just a computer program that lives on the blockchain. So, it's a set of functions and some data. So, you probably all used smart contracts if you've ever transferred a token on the Ethereum blockchain. So, that would be an example. Smart contracts, let's say a cryptocurrency token where each function, its functions are basically methods for transferring the token and has a state, which is a balance sheet, which states how much of a particular token a particular user has. Example interaction with the smart contract is when Alice sends Bob some tokens. So, for example, here Alice sends 3 tokens to Bob. This is what it looks like on the surface, but in reality, what happens is this: Alice actually interacts with the smart contract. Tells it, I want to transfer 3 tokens to Bob, and then the state is altered so that the balance, Alice's balance gets subtracted by 3, and Bob's balance gets added by 3. So, and for this, Alice had to pay some Ether on the Ethereum blockchain. So, transactions cost gas, and this is a problem for newcomers. Obviously, Alice knows this, she's aware of this, she's familiar with the concept, so she doesn't mind paying a little bit of Ether to send some tokens to Bob. But the problem is, when we have some average Joe, do we want to introduce him to our new application on the blockchain? We say, hey, check out our cool new voting app on the blockchain. He says, oh, nice. Here's a device, we give him a hardware wallet or something, so use this to cast your vote, interact with the smart contract. So that's very cool. Then you say, but first, before you do this, you have to make an account on an exchange, you need to give them your data, put some money on the exchange, buy something called Ether, you get this on your hardware device, and then you can actually use it. And he goes, what? So this is obviously a problem. Another huge problem with this is that, I don't know, maybe you saw this like a month ago, there was a transaction on the Ethereum blockchain. A person sent 0.1 Ether, but by mistake set the gas price wrong, so he ended up paying close to $300,000 just for this transaction. Obviously, I don't know the details of this transaction, why this happened, but it looks to me like a mistake. So this is something that we want to avoid, especially for newcomers and people who are just getting into blockchain. So we want to develop user-friendly apps where people won't be intimidated. So because whenever you try to get people to onboard on your application, you're intimidated just by the word cryptocurrency because of, I don't know, media or something, and obviously gas prices are difficult to predict. You need external tools to help set the gas price because prices fluctuate depending on the saturation of the network. For example, if there's lots of transactions on the network, you need to pay more for a transaction to get it through in reasonable time. So our challenge was how to remove the burden of dealing with cryptocurrencies from average users. And first, a naive solution would be to actually just, as part of the transaction, just let the smart contract refund the gas to the person who's doing the transaction. So here, for an example, when Alice sends Bob 3 tokens, the smart contract would, as part of the transaction, calculate how much gas was required and just refund this gas back to Alice. Now, the problems with this are that Alice still needs some initial funds to initiate the first transaction. Then she also needs to estimate how much gas she needs to actually execute this transaction. And the smart contract also needs some funds there so that it can send a gas back, because obviously the gas that is spent on transactions does not go to the smart contract. It goes to miners that mine transactions. So this is what they make money from: block rewards and obviously fees from transaction. So we came up with a better solution: message signing. Okay, so for those of you that don't know, apart from just signing transactions, you can also use our private key on the blockchain to cryptographically sign a message. Basically what this means, when we sign a message, we have a way then to determine that this message was actually signed by the person who holds the private key. So smart contract can actually use this logic to determine the authorship of the person who signed a particular message. So how does this help us with transactions? Well, first I need to demonstrate how this works. So for example, Alice's address, this is a made-up Ethereum address. She signs a message called Hello World, and she gets a signature of this message. So obviously this signature is unique just to Alice. If somebody else would have signed this signature would be different. And then the smart contract have a possibility to use a function. It's not called recover, it's something else. It's EC recover, but for in case of simplicity, we use recover here. You can check the message Hello World and the signature, and the result would be Alice's address. So we can use this to actually alter our smart contracts to use signatures to let's say transfer tokens. So for example, if we had one method called transfer, where the arguments were how much and to whom, we can update this and to transform it into 3 methods. So basically we keep one transfer, which is a public method, so that the contract can still work in the previous way. And then we add two more methods. One is a public method that accepts the amount, the destination, and the signature. And another is an actual function that will perform this. I think this is too technical for the scope of this talk, so but bear with me to understand this. So with these changes to the smart contract, the transaction will now look like this. Alice signs the message, transfer 3 tokens to Bob, and sends it to the smart contract as part of the transaction. And here what happens is the balance of Alice, the person who is sending is actually calculated from the message. Okay, but in this transaction that I'm demonstrating now, Alice would still pay for gas. However, the smart contract doesn't really care who sends the message. Anybody can send the message. As long as Alice signs it, the smart contract will know that she is the one that wishes to send tokens. So what we can do now is create an off-chain database of signed messages from people that wish to transfer tokens. Now, anybody can take these messages from this off-chain database and send them to the smart contract as part of the transaction. So somebody else will pay for gas, the person who will actually execute the transaction. Who is that? It can be the owner of the contract. So for example, at CargoX, where people are using our smart contracts, we pay for gas because they are our customers, and then we invoice them separately for our services. So they are not even aware that gas consumption is part of the service. There's another strategy. Anybody could execute this transaction. We could modify the smart contracts to include a reward for people who execute transactions that are waiting in the database of messages. So in reality, then it would look like this. So Alice would send a message and signature to this off-chain database. Bob would also do it, and then some third party would take these messages, spend money on gas to have them executed. Now, since all these messages are signed, this third party cannot tamper with these messages. So the if the third party would try to change, let's say, that instead of transfer 3 tokens to Bob, transfer 3 tokens to somebody else, the signature wouldn't match. So the transaction wouldn't be valid. Okay, but with this solution comes another set of issues. So for example, what happens if the same message gets submitted to the smart contract multiple times? So Alice signed the message, transfer 3 tokens to Bob, and somebody sent it to the smart contract, and then somebody else also sent the same message to the smart contract. So in reality, then Alice would send 6 tokens to Bob, and obviously she doesn't want that. So we need to make sure that messages are only valid once. And how do we do that? We introduce a concept that's it's fairly known in the blockchain world. We call it a nonce. A nonce is actually an arbitrary number that's only used once. That's the definition of a nonce. So basically, with each, we just add one number to each message and add some logic to the smart contract to only allow execution of a message with a unique nonce once. So for example, our messages would then look like this. Instead of transfer 3 to Bob, we would also add a nonce. So a nonce is the most simple way would be just use an integer and increment it each time that we do a new transaction. Also, when transactions are signed on the Ethereum network, it works in the same way. So for example, if you send some Ether to some person, nobody can execute your transaction twice because it has a nonce, which is incremented with each transaction. Okay, another issue that happens is a lot of, let's say, cryptocurrency tokens on the Ethereum network use the same contracts. Like a lot of ERC20 tokens use the same template, they use the same smart contract. So for example, what would happen if 2 distinct smart contracts would use the same message format? For example, transfer number of tokens to whoever. So what would happen then is that somebody could take Alice's message that she wanted to send token A to Bob and use the same message to transfer token B that obviously Alice also has and send it to Bob as well. To prevent that, we can also use, we can also just add the address of the smart contract itself into the message and have the smart contract validate its own address against this. So just, so for example, this is the address of token A. So this message wouldn't be valid on any other token than the token that is smart contract is located at this address. Okay, and this brings us to our final issue, is that the user needs to know what she's signing. So basically, imagine that you have an application, you're trying to do some action, but then your hardware wallet or whatever prompts you to, now you need to sign a message to actually do this, action that you wish to do. And the problem is that sometimes these messages are cryptic because it's not as simple as just transfer 3 tokens to Bob. It's usually there's a lot more data there, and it gets hashed into a number. And so when you're, let's say you're using your ledger or PC Vault or whatever, when you see you need to sign this message, and it's just a bunch of gibberish. And this is a problem that's actively being solved on the level of whole Ethereum. So basically, there are people that are coming up with standards for these messages. So this will enable us to actually do this. So for example, this is MetaMask. So this is, for example, the current state. You would see like a message that you're about to sign looks something like this. This is a hashed message of the thing that we said that Alice wants to send tokens to Bob. And this is an example of what it should look like. So once this standard is implemented, all the wallets, all the hardware wallets will also need to implement it so that on their little displays, you will be able to see something like this, what exactly you are signing. Currently at CargoX, we are overcoming this by actually, before the user signs something, we hit them with our own pop-up explaining what the user is signing right now. And it's also an easy way to actually have them validate this number. We can display this number on our application and say, yeah, you are signing this, and this means that you are transferring this document to person so and so. Okay, so to conclude my talk, I've actually explained how to use messages instead of transactions to overcome paying for gas for people that are using your application. I've explained what replay protection is. Basically, replay protection is what I've been talking about, that you cannot use the same transaction twice. And I've shown you typed messages that are being developed right now. And the most important thing is, all that I've explained here, we are using in production in CargoX. So this is really important for our users. They don't have to worry about purchasing Ether. They don't have to worry about the price of Ether, the sending of gas. All they know is that they have the hardware wallet. Their tokens are stored there, and they can send them easily just by signing the message. They say, yes, I want to do this. I'm going to sign the message. And then our service takes these messages, pays for the gas, and executes those messages. Okay, so thank you for your attention.